my party, we're just getting started. A life is a dream or a nightmare scarring. Hand me a drink cause I think I'm going all in. Get me a shrink who can catch me when I'm falling. Cover up my scars, flip the handlebars, crashing in my car, wake up in a bar. I'll be a superstar, just on my avatar.
Good morning everyone and welcome to my channel. Before we begin, let's take a look at the final model. Let's see how there are essential two distinct structures that intertwine and intersect to form this complex shape. So we have the inner structure here and the outer structure here. The algorithm is written in such a way that the thickness of the structure depends on the distance from the central axis of the geometry. This is the central axis that I draw in Rhino. And the dimension of the structure in relationship to the distance of the axis is driven by these two graph mapper of this part of definition. But let's move forward and see how the algorithm is structured. Let's start by creating the base shape. So let's eliminate this preview here and preview here. And we are going to see how the outer shape is created. The outer shape is hosted here in loft and here. So basically we have two surfaces that are intersecting together. And so let's see first how to achieve this composition of structures. So we start by creating the base shape, which consists of a pipe with a radius of 5, using any Rhino curve that I imported through the curve parameter here. Now let's select the curves in the transverse direction to the axis of the pipe, which are collected in the view output of the isocurve. So I'm going to use isocurve here and select the transversal curve that are hosted in V. And so this is the result. As input for UV, I create a range of 44 values ranging from 0 to 1, because the domain of the range is 0 and 1. So I obtain 44 values from 0 and 1. And I use the point, construct point, somewhat improperly, but only towards the collection of UV values that I need to enter into the isocurve. Now I have this 44 transversal curves. My goal is to start with these curves, modify them, and base it on the modified curves, construct a new non-trivial surface like the original one. To achieve this, I will scale each curve relative to its center by an amount generated using a graph mapper. Naturally, I will input the values from the range because I need precisely 44 values ranging from 0 to 1. Precisely the exact amount of the slider. Let me show you how I made. This is the part definition we are talking about. So we take the curve, we use area to individuate the center of each curve, and then we use scale to scale the initial geometry, initial curves of this factor. The factor is obtained inserting the range output inside this graph mapper, and from the graph mapper the output will define my factor of scale. Please remember to flatten both the input of geometry and the curve and the center, sorry. So we connect the graph mapper to the scale command. In the scale command, we'll input the transverse curve as input geometry, the center point as the center point of the scaling, and the output of the graph mapper as the scaling factor. And this is what we will obtain. Remember to flatten both G and G before scaling. Okay. Now we obtain the surface starting from this collection of points. So we loft this surface, loft this curve, and obtain the first surface. Now we go into the slightly more complex part, which involves generating the second surface that I created here. We will perform basically the same operation as the first, but we'll work on the radii. To ensure that the two surfaces intersect, the radius of one surface must be sometimes smaller and sometimes larger than the original surface. So we will divide the list of radii into two lists. In the first list, we will put the first, third, fifth values and so on. In the second list, we will put the second, fourth, sixth values and so on. To do this, then we will take the values from the first list and increase them all by a certain amount, while for the second list we will decrease them by a certain amount. At this point, all that remains is to rejoin the two lists to obtain the list of radii needed to create the second structure. So basically, we take the radii of the first structure after the radius coming from the graph mapper. So the radii after scaling, the 44 radii we have. Then we divide this curve, this list in two parts, and we do it with dispatch, assigning a pattern of 0 and 1. And then I obtain two lists of radii. The first list, I'm going to increase the quantity here in the first list and decrease the quantity here in the second list. And then I'm going to wave, so to merge together this list, but merging this list with the pattern, with the same pattern that I used to divide the list. At the end, what I obtain is a list of radii that is different from the previous, and if I use the same scaling here but I change the factor using the factor exiting from wave. The result that I obtain is basically this. And if I loft this, I obtain the second surface. Please pay attention to this part of the definition that I use before applying the loft. Before applying the loft, in this case, we will manage the seam of the curves in such a way that we perform a kind of shift of the hexagonal structure we are going to build relative to the base surface. We will understand this part after, because now we starting from these two surfaces that are hosted into the lost command, we are going to build two hexagonal grids on the surface. So we apply this hexagonal structure from Launchbox plugin. We assign the same value in both the structure, structure. So we apply this hexagonal structure to the first loft structure, and we create another component exactly the same to the second. But in the U value, I will use a slider to define the U value and another slider to assign the V value. The U value of the first structure will be directly from the slider, and the V value will be of the first and the second structure will come directly from the slider. But for the U value of the second structure, we will have to increase the value of 2. We multiply this slider for 2 and then enter into the hexagon list. And so basically at this point we have this configuration. So we have the grid in the first structure and the grid in the second structure here. Now we have the grid, and so what we have, basically we can shift the grid with this part of definition. We can rotate the grid of the second structure inside the basic surface, and if you want to see it, I can enable this, and let show you what happened when I move this. Okay, you can see that the hexagonal grid change its position in relationship to the basic surface. So the hexagonal grid remain inside the hexagonal inside the structure, but it can rotate inside the structure. Okay. Now in this section of code, we will link the thickness of the elements of the final structure to the distance from the axis of the structure itself. So apply curve closest point to identify the distance of each node of the hexagonal grid from the axis. So the curve is the input curve is basically the curve that I drew in Rhino. Then we remap the values to be within an interval between 0 and 1 using a graph mapper. So this we remap inside a target of 0 and 1, and then we use these values to enter inside this graph mapper that will define the dimension of the structure in relationship to the axis, or to the distance from the central axis. So less distance, more structure, more bigger will be the structure. And after that we apply multi-pipe using the curves. The curves are coming from hexagonal structure here. Node sides will come from the graph mapper here. Sides point will come from nodes. Now all we have to do is to repeat the second this part of the code for the second structure is exactly the same. Now if I enable this part, and I also enable the preview here, I can see how this graph mapper works. It will take some time because the structure now is big, but if I move basically this point up, what I see is that I'm working in the point that are next to the the central axe. So for example, this point, if I go up, are basically increasing the thickness of the surface. If I want this part to be bigger, I'm talking about the inner structure in this point, so I go up with this curve here. And I can basically do the same with the other structure. So I will take the second graph mapper. I want to increase the dimension of the structure here. I can do it moving the second point. Okay, and if I want to rotate the second structure, I can do it. Do you remember with this command we use, this same command we use before entering into the loft? And then you have the rotation. And if you want to move to change the overall form, is it possible? It will take some time because after this we have created a lot of definition, but you can move this graph mapper and you have two surfaces that still intersect themselves, and because we create this part of definition that regulate this kind of transformation, and in this part you can generate every time 44 radius, and if you want to increase the number of radii, is possible only using this slider here. So if you enjoyed the video, I asked you to subscribe to my channel and hit the notification bell. Wishing you good work and a wonderful day.